Welcome to 15-Minute Discourse. Today we're diving deep, into the world of AI and language.
Yeah.
Specifically, we'll be looking at the paper that kind of kicked off this whole large language model craze.
Okay.
Improving Language, Understanding by Generative Pre-training.
It's a landmark paper for sure.
Absolutely.
Yeah.
This paper changed how machines understand and generate human language.
Right.
To get the full picture, we'll be using the paper itself, obviously,
Okay.
but also some Wikipedia articles on deep learning and large language models,
Got it.
and even a textbook on machine learning.
Sounds like a comprehensive deep dive.
It is. Get ready for some fascinating stuff about neural networks,
Okay.
huge data sets, and how all of this is already woven into our lives.
Yeah.
I'm really excited to get into this.
Me too. It's amazing to see how the ideas in this paper have grown and spread.
Okay, so before this paper dropped in 2017, things were different.
Yeah.
We need to set the scene.
Okay.
Language models weren't what they are today.
Right back then, it was all about enneagram models.
They analyze sequences of words to predict what comes next.
Okay.
It's like trying to guess the next word in your favorite song.
Okay.
You use the melody and the words you've already heard to make a guess.
Like if I said, Mary had a little?
You probably say lamb, right?
Right.
Exactly. But these enneagram models had limits.
Yeah.
They couldn't truly grasp the complexity of human language.
Mm.
Imagine trying to understand a whole symphony by only listening to a few notes at a time.
Got it.
You'd miss the overall structure and the finer details.
Makes sense. But even with those limitations, it sounds like things were still moving forward before 2017.
Oh, definitely. Researchers were already doing some amazing things.
Okay.
For example, back in the 1990s,
Okay.
IBM was a pioneer in statistical language modeling, especially with their alignment models.
Okay.
And get this, in 2001,
Right.
they trained a smoothed enneagram model on a data set of 0.3 billion words,
Wow.
which was huge at the time.
Yeah.
It achieved state-of-the-art perplexity.
Okay. Basically a measure of how well a language model can predict a sequence of words.
Wow, 0.3 billion words.
Yeah.
That sounds like a lot even now.
It was a massive amount of data back then.
Yeah.
But of course, things have changed dramatically since then.
And that brings us to the real game changer.
Yeah. Deep learning. Deep learning really shook things up.
Yeah.
Not just in natural language processing, but in so many fields.
Okay.
It allowed models to learn complex patterns from massive amounts of data.
And it's all thanks to those neural networks we hear so much about, right?
Precisely, neural networks are algorithms inspired by the human brain.
Okay.
Imagine layers of interconnected nodes like neurons processing information.
Got it.
Each node takes input from other nodes, does a simple calculation, and then passes its output to other nodes.
Okay.
It's all about adjusting the connections between these nodes so the network can learn to recognize patterns and make predictions.
I'm trying to picture it like a vast network of connections constantly learning and adapting as it processes information.
That's a great way to think about it.
Yeah.
What's fascinating is that the idea of these multi-layered networks, or MLPs, goes way back to the 1950s with Frank Rosenblatt's perceptron.
Wow.
Things have become much more sophisticated since then,
Yeah.
but the core idea remains the same: mimicking the brain's way of processing information through interconnected pathways.
So how do these networks actually learn?
Yeah.
It's not like there's a teacher standing over them, right?
Not exactly a teacher, but there is a crucial process called backpropagation. It's an algorithm that allows the network to learn from its mistakes, essentially.
Okay, explain backpropagation like I'm 5. How does it work?
Imagine you're learning to ride a bike.
Okay.
You're wobbly at first. You might even fall a few times.
Yeah.
But each time you fall, you get feedback.
Okay.
You learn what not to do. You adjust your balance and steering based on that feedback.
Got it.
Backpropagation is kind of like that.
Okay.
It allows the network to adjust its connections, its internal weights, based on how well its predictions match the actual data.
Yeah.
If the network makes a wrong prediction, the error is sent back through the layers, and the connections are tweaked to avoid that error next time.
I like that analogy.
Okay.
So backpropagation helps the network learn and get better over time.
Right?
And this idea has been around for a while, right?
Longer than you might think.
Huh?
The groundwork for backpropagation goes way back to the 1670s,
Wow.
with Gottfried Wilhelm Leibniz and his development of the chain rule.
Hmm.
But the form we use today
Okay.
was first published in Seppo Linenma's master's thesis in 1970.
Wow.
Amazing, right?
Yeah.
However, it took until the 1980s for researchers like Paul Werbos to really start applying it to neural networks.
So all of this,
Yeah.
the neural networks,
Yeah.
backpropagation,
Right.
it all part of the bigger world of deep learning.
Exactly. And within deep learning, there are specific types of neural networks that have proven incredibly useful for language processing.
Okay.
Two of the big ones are convolutional neural networks, or CNNs, and recurrent neural networks, or RNNs.
CNNs, I think I've heard of those.
Yeah,
Don't they use them for image recognition too?
that's right. CNNs were originally inspired by the visual cortex,
Hmm.
the part of our brain that handles sight.
Okay.
They use a process called convolution, which is like sliding a filter over an image to pick out features.
Okay.
It's fascinating how a technique from one field can be so useful in another.
Yeah.
Shows how math connects seemingly different areas.
So what about RNNs?
Yeah.
What makes them special for language?
RNNs are built for sequential data, like text or speech.
Okay.
They have a kind of memory that lets them remember previous inputs when they're processing new ones.
Got it.
This is key for understanding the context of words in a sentence.
So unlike those early anagram models that only looked at a few words at a time, RNNs can see the bigger picture.
Precisely. And one particularly powerful type of RNN is the long short-term memory network, or LSTM.
LSTMs. I've definitely come across that term before.
Yeah.
They're a big deal in AI, right?
Yeah. They became so good at speech recognition that by 2003 they were already rivaling traditional methods. And by 2009 they were winning pattern recognition contests. It was becoming clear that these deep learning approaches, particularly those using LSTMs, could achieve remarkable results.
Yeah.
But of course, there was still room to grow.
And that's where the Improving Language Understanding by Generative Pre-training paper comes in, the one we're focusing on today.
You got it. This paper marked a real turning point.
Okay.
It introduced a new way to train language models, a way that focused on generative abilities.
Generative, what does that actually mean?
It means training a model to create new text, not just understand existing text. It's like the difference between reading a book and writing one.
Whoa, that's a whole other level. So before this, paper language models were mostly about tasks, like predicting the next word
Yeah,
or figuring out the sentiment of some text.
right.
But this paper said, let's train a model to generate new text that's coherent, grammatically correct, and hopefully meaningful.
Yeah.
That's pretty wild.
It was a big shift, and this paper didn't just introduce the generative approach, it also unveiled a powerful new architecture called the transformer.
The transformer. This is where things get really interesting. Tell me more about this transformer and why it's so special.
One of the biggest issues with traditional neural networks, especially RNNs, was that they processed text sequentially, one word at a time.
Okay.
This was inefficient, making training very slow, particularly for long stretches of text.
Yeah.
The transformer changed all that.
How so?
It introduced this mechanism called self-attention,
Okay.
which lets the model process all the words in a sentence simultaneously.
Wow.
This was a game changer, leading to huge improvements in training speed and performance.
Yeah.
Remember how we talked about deep learning needing serious computing power? Well, this is where advancements in hardware, specifically powerful GPUs, played a critical role.
Yeah.
They were essential for developing these large, complex models.
It's amazing how it all comes together.
Yeah.
The algorithms, the hardware, the massive data sets. It's like a perfect storm that led to this explosion of AI capability.
And the Improving Language Understanding by Generative Pre-training paper was right at the center of it.
Okay.
The model they introduced, which later became known as GPT, was trained on a massive data set of text and code.
Okay.
This allowed it to learn a huge range of linguistic patterns and even programming concepts.
Wow.
It set the stage for the LLMs we see everywhere today.
So how does all of this affect us regular folks?
Yeah.
Have these LLMs really become that much a part of our lives?
More than you might think. Think
Right.
about those smart assistants we use every day.
Yeah.
They understand our questions and respond in a way that feels almost human. Or the machine translation tools that let us communicate across language barriers with increasing accuracy.
Right.
These are powered by LLMs.
Oh, what about those chatbots that pop up on websites?
Exactly.
Some of those are getting really good.
Exactly. Some of those are getting really good. Those chatbots can hold surprisingly human-like conversations, thanks in part to advancements in LLMs.
It's incredible.
And this is just the beginning.
Really?
LLMs have opened up a whole world of possibilities in areas we might not even think about.
Like what? Give me some examples.
Well, in education, personalized learning tools can adapt to individual students' needs.
Okay.
In healthcare, LLMs are being used to analyze scientific literature to speed up drug
Oh,
discovery.
wow.
And in the creative world, they're assisting with writing, generating content, and even composing music.
It's mind-blowing how far we've come from those early enneagram models, from simply predicting the next word to helping discover new drugs. That's an incredible leap.
And it all started with this one groundbreaking paper.
Yeah.
It shifted the focus from understanding to generating, and that has had a profound impact on AI and how we interact with technology today.
This has been an incredible journey so far, and we're just getting started. After a short break, we'll dive even deeper into the specific contributions of the Improving Language Understanding by Generative Pre-training paper and explore what makes this specific paper so groundbreaking.
It's amazing how this one paper, Improving Language Understanding by Generative Pre-training, sparked a revolution in natural language processing. It's like they planted a seed that grew into this incredible forest of LLMs we have today.
So let's get into the specifics of this paper. What exactly did they propose that was so different from what came before?
Well, as we touched on earlier, the big shift was this idea of generative pre-training.
Okay.
Instead of training a model for a specific task like translation or question answering,
Right.
they trained it on a much broader task,
Okay.
predicting the next word in a massive data set of text.
Hmm.
This allowed the model to learn a much wider range of linguistic patterns and relationships, giving it a more general understanding of language.
So instead of focusing on one narrow skill, they basically gave it a general education in language.
Exactly. And the model they used, the transformer, was specifically designed to handle this kind of massive data.
Right.
Remember that self-attention mechanism we talked about?
Uh-huh.
That was key to allowing the model to efficiently process all those words and learn those complex relationships.
Right. It could see the whole sentence at once instead of going word by word. But why call it pre-training?
Hmm.
What comes after the pre?
Good question. The idea is that once the model has been pre-trained on this massive data set, it can then be fine-tuned for a specific task.
Okay. So it's like they gave it a broad foundation in language,
Hmm.
and then they could specialize it in a particular field, like a student who gets a general degree and then goes on to get a master's degree in a specific subject.
That's a perfect analogy. They have a solid base of general knowledge, but then they can apply that knowledge to a specific area.
I like that. So it's efficient. You don't have to start from scratch for each new task.
Exactly. You leverage the knowledge the model gained during pre-training.
Yeah.
And what's really cool is that this pre-trained model can be fine-tuned for a huge variety of tasks.
Right.
With relatively little additional training data.
It's like they created this multi-talented language whiz that could be molded to excel in any area you needed.
Precisely. And the results were impressive.
Hmm.
After fine-tuning, the model performed exceptionally well on a variety of tasks,
Okay.
including natural language inference, question answering, and sentiment analysis.
Wow.
It was a clear demonstration of the power of generative pre-training and the transformer architecture.
And this one paper really set off a wave of innovation. Think about all the incredible LLMs we have today, like ChatGPT, Bard, and so many others.
Yeah.
They're all built on the foundation laid by this paper.
It really shows the power of fundamental research and how one idea can change the world. And what's exciting is that the field is constantly evolving.
Yeah.
New architectures are being developed, training data sets are getting even larger, and researchers are constantly pushing the boundaries of what these models can do.
It makes you wonder what the future holds for LLMs.
Yeah.
If we've come this far in just a few years, imagine what's possible in the next decade or two.
It's a really exciting time to be following this field. The possibilities seem almost limitless now. Having said that, it's also important to understand the technical details of what makes the transformer architecture so special and how that enables these generative capabilities.
Okay, let's get technical then. Break it down for me. What's so special about the transformer compared to those earlier architectures?
Well, the key innovation of the transformer is the use of self-attention mechanisms. Remember how RNNs process text sequentially one word at a time?
Mm-hmm.
That limited their ability to capture long-range dependencies in language.
Like how a word at the beginning of a sentence can affect the meaning of a word much later on.
Exactly. Traditional RNNs struggled with that. But with self-attention, the transformer can consider the relationship between any two words in a sentence, no matter how far apart they are.
Wow.
It's like the model can focus its attention on the most relevant parts of the input, just like we do when we read or listen.
So it's not just going through the sentence step by step. It's analyzing the whole thing at once and figuring out which parts are most important.
That's right. And this has huge implications for language understanding. For
Okay.
example, let's say you have a sentence like, the cat sat on the mat, which was blue.
Okay.
A traditional RNN might have trouble remembering that which refers to the mat, not the cat.
Hmm.
But with self-attention, the transformer can easily make that connection.
That makes sense. It's like the model has a better grasp of the overall context.
Exactly. And this ability to understand long-range dependencies allows the transformer to generate much more coherent and fluent text.
Okay.
It's also much more efficient because it can process all the words in parallel, unlike the sequential processing of
So
RNNs.
it's smarter and faster. It's kind of a big deal.
It is, and that's why the transformer has become the dominant architecture for LLMs.
Hmm.
It's the foundation for models like GPT-3, BERT, and all the other amazing language models we see today.
It's incredible how this one architectural innovation has had such a massive impact.
It really is, and it all comes back to that fundamental idea of self-attention, which allows the model to capture those crucial relationships between words, no matter how far apart they are in the sentence.
So this self-attention thing is really the secret sauce of the transformer. It's what allows it to understand and generate language in such a sophisticated way.
Precisely, and it's one of the key reasons why the Improving Language Understanding by Generative Pre-training paper was so groundbreaking. It introduced this powerful new architecture and demonstrated its potential for revolutionizing the field of natural language processing.
You know, it's fascinating to think about the journey of these language models from those early anagram models struggling with a few words at a time to these massive self-attentive transformers that can write poems and compose music. It's been a wild ride.
It really has, and the journey isn't over yet. The field is constantly evolving, and we can only imagine what amazing things LLMs will be capable of in the years to come.
I can't wait to see what the future holds. But before we get too carried away with future predictions, I think it's important to circle back to the Improving Language Understanding by Generative Pre-training paper and highlight some of the specific ways it changed the game. What were some of the key contributions that really stood out to you?
Well, apart from introducing the transformer architecture and the concept of generative pre-training, which we've already discussed, I think one of the most important contributions was the sheer scale of their experiment. Remember how those early Enneagram models were trained on datasets of hundreds of millions of words?
Yeah.
Well, the GPT model in this paper was trained on a dataset of billions of words that was unheard of at the time.
Wow, billions. That's a massive jump in scale. What difference did that make?
It made a huge difference. The larger the training data set, the more diverse the patterns and relationships the model can learn. And that leads to better performance on a wider range of tasks. It's like the difference between learning a language by reading a few books and learning it by immersing yourself in a culture for years. The more exposure you have, the more fluent and nuanced your understanding becomes.
That's a great analogy. So basically, they supercharged the model's learning by feeding it a massive amount of text data.
Exactly. And that was only possible thanks to the advancements in computing power we talked about earlier, that those powerful GPUs made it feasible to train these massive models on such huge data sets. It was a real turning point in the field.
It's amazing how those hardware advancements enabled these algorithmic breakthroughs.
Yeah.
Like they went hand in hand.
They did, and the impact was undeniable. The results in the paper showed that this combination of a novel architecture, massive data, and powerful hardware led to significant improvements on a variety of language tasks. It was clear that they were onto something big.
And it wasn't just about the performance improvements. This paper also opened up a whole new way of thinking about language models. Instead of viewing them as specialized tools for specific tasks, they started to be seen as general-purpose language understanding and generation machines. That was a paradigm shift.
Absolutely. And that shift in thinking has had far-reaching consequences. It's what led to the development of the incredible LLMs we see today. Models that can translate languages, write different kinds of creative text formats, answer your questions in an informative way, and even generate code. The possibilities are seemingly endless.
It's like they unlocked a new level of language capability in machines, and it all started with this one groundbreaking paper.
It did, and while the field has advanced significantly since then, the core ideas presented in this paper remain incredibly influential. It's a classic for a reason.
It's amazing how one research paper can have such a lasting impact.
It really is. It shows the power of curiosity, creativity, and a willingness to challenge conventional wisdom. The authors of this paper saw something that others hadn't, and they pursued it relentlessly, and in doing so, they changed the course of AI history.
It's inspiring to think about. It reminds us that even in a field as advanced as AI, there's always room for new discoveries and breakthroughs. Who knows what amazing things will be possible in the future as we continue to push the boundaries of language understanding and generation.
I can't wait to find out, but for now, I think we've done a pretty good job of unpacking this groundbreaking paper. We've explored its historical context, its key innovations, and its lasting impact on the field of AI. Hopefully, you now have a better understanding of how we got from those early underground models to the incredible LLMs we see today.
It's really mind-blowing to think about how much impact this one research paper, Improving Language Understanding by Generative Pre-training, has had on the world.
Yeah, it really shows how fundamental research can lead to these unexpected breakthroughs with consequences we can't even imagine.
Yeah.
Who could have predicted back then that this idea of generative pre-training would lead to LLMs that can write poems, compose music, and even help make scientific discoveries?
It's like opening a door to a whole new world of possibilities.
Yeah.
We've talked about how LLMs have changed the game,
Hmm.
but this paper specifically mentions some pretty interesting results they saw in their experiments.
Right.
What were some of those that really stood out to you?
One thing that impressed me was how well the model performed on tasks that require understanding long stretches of text, like summarizing documents or answering questions based on a paragraph of information.
Hmm.
Previous models often struggled with these tasks because they couldn't keep track of all the relevant information.
Yeah.
But the transformer, with its self-attention mechanism, could handle these tasks much more effectively.
So it's not just about generating cool text, it's also about actually understanding the meaning and the nuances of language.
Right, and that's a crucial step towards building truly intelligent machines. Another interesting result was the model's ability to perform zero-shot learning. This means it could perform tasks it hadn't been specifically trained for just by being given a few examples.
Wait, so they didn't explicitly train it to do those tasks, but it could still figure them out. That's incredible.
It suggests that the model had learned a deeper understanding of language that allowed it to generalize to new situations.
Okay.
It's like you learn how to ride a bike and then you can figure out how to ride a scooter without much effort because the underlying principles are similar.
That's a great analogy. So it's not just memorizing patterns, it's learning something more fundamental about how language works.
Exactly. And that's one of the key insights of this paper, that by training a model to generate text, we can actually teach it to understand language at a deeper level. It's a bit counterintuitive, but it works.
That's like the old saying, you don't really understand something until you can explain it to someone else.
Yeah.
Maybe that applies to AI too.
I think there's something to that. The act of generating language forces the model to think about the relationships between words and ideas in a way that simply analyzing text doesn't. It's like a writer who learns more about their subject by trying to write about it than they do by simply reading about it.
I like that. So by challenging these models to create something new, we're actually pushing them to understand language more deeply. And that deeper understanding then translates into better performance on all sorts of tasks.
That's right. It's a virtuous cycle. And it's one of the reasons why generative pre-training has become such a dominant approach in natural language processing. It's not just about generating cool text, it's about unlocking a new level of language understanding.
And this paper really laid the groundwork for all of that.
It did. It was a landmark achievement that changed the way we think about language models and opened up a world of possibilities. And even though the field has progressed rapidly in recent years, the core ideas presented in this paper remain foundational. It's a classic for a reason.
It's amazing how one research paper can have such a lasting impact.
It really is. It shows the power of curiosity, creativity, and a willingness to challenge conventional wisdom. The authors of this paper saw something that others hadn't, and they pursued it relentlessly. And in doing so, they changed the course of AI history.
It's inspiring to think about it. Reminds us that even in a field as advanced as AI, there's always room for new discoveries and breakthroughs. Who knows what amazing things will be possible in the future as we continue to push the boundaries of language understanding and generation.
Yeah, I can't wait to find out.
Me too. But I think we've done a pretty good job of unpacking this groundbreaking paper today.
Yeah.
We've explored its historical context, its key innovations, and its lasting impact on the field of AI. Hopefully, you now have a better understanding of how we got from those early anagram models to the incredible LLMs we see today.
It's been quite a journey.
It has, and you know what? I think it's a perfect example of what we try to do here at 15-Minute Discourse. We take these complex topics and break them down in a way that's hopefully informative and engaging, so you can walk away feeling like you've learned something new and exciting.
I agree. It's all about making knowledge accessible and empowering people to understand the world around them a little bit better.
Well said. And on that note, we'd like to encourage all of you listening to like, subscribe, and share this episode with anyone who might be interested in learning about the fascinating world of LLMs and the research that made it all possible.
Thanks for joining us on this deep dive. We'll see you next time on 15-Minute Discourse.